Thanks everyone. Thanks for joining to one of my uh, Python tutorials on how to manage instance attributes and how to effectively write cleaner code and more maintainable code so that you don't expect errors as such, and have the object-oriented programming principles in place so that you can avoid the common pitfalls and such. In the last video, I was explaining about the uh, r- how the inner machinery of Python works when you create an object of a class type. Let's say person here. Person is an example of type here, and we try to create a person object, and we try to see what are the instance attributes of that particular object if we are instantiating an object from that for that class, and the how we can there is no way, no way, at least if we don't take care of it, it's possible to create data of wrong type and also create more intense attributes out of the fly, which we don't want, if there's a mistake as such. So this is something that we saw earlier. So just to give a recap, um, so here you see there's this salary which is supposed to be int, but it's not. It's a string now, and address with an s less. It's a new attribute that we created. Maybe it's a typo created unintentionally. So we address that through the getters and setters uh, as we would maybe in Java, but we don't really actually do with the uh, manipulate the type stuff in Java because it is strongly typed. But Python, since it's not strongly typed, we have to take care of this scenario. We just take if it's an instance of type, salary, then try to update the value. If not, raise an error, and we saw that error being reported as we would expect. So let's say if we give an if we give an attribute of which expects to be an integer, but it's not, let's say, then we would get an error, age expected as an integer, but we got a value instead. So this is one of the error that we wanted to have. This is the functionality that we wanted to have. But then there is another issue here that we mentioned, we talked about earlier, creating instance attributes out of the fly. So that's an issue that we still haven't talked about. So I'm going to address that here. So in order to do that, we just need to talk about how the inner machinery of Python works. You know, I thought I'd better go with the other approach of giving the right types uh, uh, for the object that we want, that we are creating, so that we kind of ease into the problem that uh, that we had. So here, let's say, let's say, what if we don't want to have this boilerplate? So because that's why Python shines. You can prototype an application faster and you can create an application. But this is boilerplate. This is typical Java stuff, and we don't want that. In order to do that, we can take use of Python's inner machinery. So there's a get method and set method. These are magic methods, dunder methods, as I mentioned before. Uh, these are something that you define so that uh, you can make the particular class uh, work in such a way that it replicates some of the behavior as other objects. Let's say here we have the double underscore get method and double underscore set method. So let's say if you have a dictionary, okay, dict equal to let's say the key becomes the name, maybe my name, and the value becomes a number, let's say, and uh, you would be knowing the get method in the in a dictionary. Let's say it's you just give the get method and you give a key here, maybe Vivek, and again there's another way to access the particular values, and this is one way, as you already know. uh, so this is another way of accessing that particular key and retrieving the value. So this, if you see the line number 58, so this uses this machinery, the underscore get method. If you go into the dict dot you know dot double underscore the dict method, you would find that there's a method called double underscore get that's been already declared by Python for us. So I'm not going to do that now, but you can check that later. But that's the inner machinery. So that's how we actually get the value for this Vivek key. If I give this particular, if I access this access through this way, so we are actually using that machinery here, to get and set the names that we want. Okay, uh, if you see, we are making a check here. Let's say if a particular data type, if a particular instance attribute is an integer, we only should be getting an integer value, integer type, and we should not get any other type. So that's the basis of this piece of code. And the reason why we have get method is that to check if that particular instance type, if a particular attribute is of integer type. So same goes for string type. It's just again boilerplate. I'm just copying the same thing. If you see here, age, I'm creating a class. Sorry, I'm creating an object instance of integer type, and I'm giving the name age. And again, salary is of integer type, and name is of integer type, and we are actually giving the name of the instance attribute as well. The reason for doing that is, let's say if I run this piece of code, we would expect that we would get thrown an error. You see, because we actually get the age attribute. So let's say here we try to get the age attribute for this example. And what's an age attribute? That's an integer. We are initializing through integer, and try to set that. So this is the set method that I was talking about. This is equivalent to, let's say, to our previous example, setting up a new variable in a dictionary. Vivek equal to 1. It was 1 earlier. Now it's equal to 100. So yeah. So this is the whole idea behind the scenes for this, the inner machinery. So now all I have to do is just create these three, you know, variables and try to assign the values, and we expect the same behavior as setters and getters would have achieved, but then through a different way. So that's a goal here. So yeah, so once that's done, you would have now got a fair idea about how getters and setters work. So these are inner machinery methods. Now going on top of that, we can create more types. Still we can generalize the code so that it becomes much easier, much meaning that much more maintainable. Let's say I'm having a common type. Okay, it's just a type. It has get methods and set methods. And if I create it's just if I create a type, let's say an integer, it should be of the type int, and string should be of the type str. So these are the objects that I can create. Let's say we are trying to actually uh, work. We are trying to kind of like generalize things and see how a programming language would work and do its checks, uh, as as you would. Basically, we are trying to rewrite the primitive types in Python as well. If you think of, it's kind of like that, using the inner machinery, the init, get, and set methods. So I'm more generalizing here. So all I have to do is, like, this is more readable than the other use case. Definitely, I think you would agree. So um, here, actually, I'm kind of having this integer string, and but here I don't give the names. I'm just giving the um class object types, and it would be intended what to be of the type that we would want it to have. So let's say if it is integer type, so it's going to be int. If it's a string type, it's going to be string, and that's going to be a check. So again, we are going to have the same functionality as we thought we would have as before. So these are how the getters and setters uh, get and this is something that we would want to use if you want to go into the inner machinery instead of using the getters and setters and the typical way of doing things with uh, as we would do with Java. But still you would agree that this is why would you want to do this, because this is more work than usual. We have the getters and setters in place. Why we want to have this machinery in place? Suppose consider, let's say you're trying to create an object of different type, maybe not integer, maybe person, or maybe payment gateway. Let's say you're trying to create a payment gateway and we want to have a class called payment, and it's of type different type, maybe some kind of a error code, or maybe whatever it is, right? So it's easier to do this through this way, to do a class check, uh, than having to do a getters and setters, because when your program gets more complicated, this is definitely going to help when you try to write frameworks as such. For example, adding more functionality to a framework, because you're going to create a lot of objects, a lot of types. You want to do that checks there. So instead of having relying on the getters and setters, these things would definitely help, to establish an order on the types. So that's why we would want to use there, and also to understand the main functionality of what dunder get and dunder set method does. This is inner machinery of Python, and also the set attribute, which actually uses the double underscore set method. So uh, this is what we wanted to talk about, and with this actually we can potentially stop the issue of creating the uh, instant attributes out of the fly, which we don't intend to have it in the class definition. So yeah, so that's the main goal here. So that will be shown in the next video, I guess, because this is going huge. So it's better if I split it into multiple parts so that it becomes digestible and easier to understand. So yeah, please check out my next video where I'm going to discuss uh, how do I how do I actually take care of the issue that we had uh, with this approach. Thank you.